Solar power is quiet. It doesn't make a lot of racket. It's something that you can put up pretty much in any location that has daylight. In order to do science, mathematics is the language of science. If you're going to be able to do anything productive, you have to speak the language. And that applies anywhere. So science, technology. Technology, of course, is the application of science. Engineering is the intelligent use of it. And then go back and start using math. Put numbers to it. What do you really want it to do? How many volts do you want it to put out? How much energy do you want it to convert? Over what period of time? What limits do you have on it? Things of that nature. That's one of the things I've done in my past was work in Army labs. And one of the things they had there was they're just coming in with the first of the roll-up solar panels. And wander around with the solar cell. When you need it, you pull it out, lay it out, plug in what you want, your converter if necessary, and now you've got the energy to whatever device you might happen to have. Control of the stuff is probably the hardest part. If you're going to use it for charging things, most of them are battery-based, you have to make sure that whatever you have coming out of the solar panel matches the characteristics of the battery. If you don't match the characteristics of the battery, lithium-ion batteries have some legends about them that they do things that show that they object to being charged in fashions that, well, that they're not designed to be charged for, or maybe they are designed perhaps. Is what sort of nature of the beast, and they'll catch on fire. That's one of the reasons the Navy does not like lithium batteries in their ships, because you can't put out a lithium battery fire. You have to let it burn. It burns to the ground. That's a problem in a ship. So though that's probably the biggest problem you'll run into is trying to make your solar panel, or probably you have devices on it, because putting them together and getting the voltage and power you want is pretty much an exercise in a little bit of basic math, multiply and add. But trying to get this thing so it'll behave and match what you're doing with the battery has to have in order to charge efficiently and safely, well, that's going to be where you're going to get caught. Well, I hate to sort of be crude about it, but sunny ones. Ones that have lots of light, or lots of radiation, solar radiation to come in, and you can convert to heat if you prefer the heat associated with it. So in that regard, they tend to work in places that are known for more solar radiation than others. Solar, a good example of this, solar panels work magnificently in Seattle this time of year. It's great because, of course, Seattle is sunny all the time in July and August and September. And then they work like crap the rest of the year because they don't have much sunshine in Seattle. And so you have to be careful with that to make sure that happens. If you're looking at it to be an engineer, then the classes you would take would be your math to get into engineering, since you got to speak the language. Once you have the math, then the physics, which of course is the science, physics, chemistry, things of that nature. States like Arizona have a large amount of solar energy and large amount of time that it shows up in intense form. Colorado's another good place. In those cases, the altitude has as much to do with it because there isn't as much atmosphere between the sun and the device than there is here, or even Seattle, where it's at sea level. Dollars. It's cheaper to use oil, cheaper to use fossil fuel coal. It doesn't cost as much because the process of putting the energy into the materials already got done. When it becomes more cost effective to do this, you'll see more solar power and you'll see less of those.